Just a minute, yes, it has to go. Okay. Yeah. So here finally where we are loading the data into target system, that will be calling it as a destination base, that is a target system. Okay, target warehouse may be any database. Okay, so it may be SQL Server, DB2, Teradata, Oracle. So based on the company, enterprise requirement, so there will be data warehouse is chosen, and there we will store all our data into the data marts are fact tables and dimension tables. Okay, so that is our destination class. So if you see here, you cannot directly load the data from data warehousing system from source. So we'll be extracting data from source and loading into the staging area. Again, from staging area, we'll be extracting the data after applying transformation rules. Then we will finally load into data into target system. Okay. So this is the general enterprise architecture. Okay. So this we have discussed yesterday. Now let's move on to data extraction, transformation, and loading. So we have discussed about extraction, internal source system, external source systems. Now let's move on to data transformations. So what are data transformations? We have 4 methodologies of data transformation. One is data merging, data cleansing, data scrubbing, and data aggregation. So what is meant by data merging? So data merging means combining two tables or files into a single resultant. Okay. So here we'll be dealing with 2 types of data merging. So one is similar structure, another one is dissimilar structure. So now let's discuss about dissimilar structure. Dissimilar structure means what? So there is no metadata is not common between 2 tables. So we require to merge 2 tables means the metadata here should not equal. And how we can join? We can join based on the key column. So here, if we take an example here, employer table versus department table. So here I'm comparing with employer table department number is equal to DEPT department number. So based on the join condition, we'll be combining those 2 tables data into a single resultant table. So this is dissimilar structure. Okay. And next one is similar structure. Similar structure, what happens in similar structure, the table name may be different, but inside of the tables, okay, so tables are a file, the layout is common, metadata layout is common. So in that scenario, in that case, we'll be considering as, in that scenario, we'll be considering as similar structure. Okay, so in case of, there might be a chance if you want to combine these 2 files to a single resultant union. Okay, so in that scenario, we'll consider as union. Okay, so union and make the resultant into single resultant. Okay, yeah, right. Now another thing is we have discussed about data cleansing. So make the data inaccurate. Okay, so there are some letters combined with small letters. Content comes with small letters, capital letters. We need to make a single format. All are in caps. Okay, and we'll be getting data in inaccurate format. Okay, so here you can see the sale amount $10, $7.8. So what we need to do is we need to do the round off and make it in a proper visible format. So if the data is not proper here, what happens is data is not proper. What happens is it looks like irregular. So because this data is built by top level management and middle level management, so it should be very accurate. And they see if data is not proper order, so unnecessary won't be good. So that is the reason we need to make a cleaning activity by using round off functions. Okay, so this is just a basic example. And we'll clean the data and load it into warehouse. And like next one is data scrubbing. There are some tables that is not available in source, but we need them in target. So here at intermediate level, we'll be deriving data for those columns and load it into target. For example, sales amount. Sales amount is their column. And the sales tax. Okay. So 1% of sale amount is the sales tax. Sales tax that we are not receiving from source. But we need those column in target. So in that scenario, what we will do at a transformation layer, like 1% of sales tax will be 1% of sale amount will be the sales tax. Okay. So we'll be derive the data for. And data aggregation. Data aggregation, we have seen sum of all the columns on a group by function, minimum value, maximum value, average. Okay. We have considered banking sector as an example. Monthly, they will calculate average monthly balance for account wise. Daily at 8 o'clock, they will do this transaction entry. So what is my today's monthly, today's end of the day, what is my balance? Okay. So they will add together by month. That divided by 30. So that comes around what is the value. So if it is to minimum balance to maintain as an account, then what happens is if the customer don't maintain the minimum balance, they will charge a fine according to their policy. Okay. So with the data aggregation, they will do all this calculation. Next, we have discussed about data loading. So target system, where data is loading into target system. Finally, a storage location. So next we have discussed about data mart. So what is a data mart? Data mart is a subset of enterprise data warehouse. Okay, so it deals with a specific subject. These data marts will help us to fulfill the needs of middle level management. Okay, and the next one is approaches of data warehousing. There are two types of approaches. One is top-down approach. Next one is bottom-up approach. So top-down approach was introduced by W.R.H. Schumann. What he is saying is like, let's build the data warehouse first, then we'll build the respective data marts from the data warehouse. Okay, this is his methodology of building the data warehouse. And the next approach is bottom-up approach. See, this is Ralph Kimball. So here, let's build the data marts first. So building the data marts is very easier. Okay. So once the data marts are built, then we'll integrate all the data into one enterprise data warehouse. Okay. And the next one is types of data marts. Dependent data mart and independent data mart. So here, what top-down approach is a dependent data mart, because to build this data mart, we are depending on enterprise data warehouse. Okay, and the next one is independent data mart. Okay, so in the independent data mart, what happens is bottom up approach. Here, we are not depending on this enterprise data. Okay, so we'll be building the data marts first, right? So that is the reason we'll be considering as a independent data mart. So this is very, very important question in interviews. Okay, and next we have discussed about the life cycle of data warehousing. Okay, so for any data warehousing projects, if you want to build by using any tool like ETL, DataStage, Ab initio, okay, Oracle Warehouse Builder, Informatic. So first of all, we need to understand the business requirements. Okay, so here they need to choose one reporting tool, one ETL tool. Okay, and what are the databases? What are the source systems? Where you will get the source system? In the business requirement analysis document, they will mention all these details. So once these are business requirements are clear, the next step is architects and senior tech leads, they will be focusing on building this data models. Okay, so data models. So once the data models are built, then the development starts. Okay, so ETL job sequences, the development will start. So then ETL testing will start. Once the development is completed, parallelly testing also will start. Okay, so once the testing is completed, parallelly the reporting team also will start the developing of the reports. Similarly, there is a report testing team. Okay, So internal testing team, they will take care of both ETL testing as well as the reporting testing. They have test cases prepared for each activity, what they are going to perform in the testing. Okay. So if you are loading in a table, the table should not contain duplicate data. First, they will check these kind of things. Okay. And any date fields are there in any proper format. Okay. So each table, okay. So they have some business rules. The data should be followed. Okay. So they have the particular column data should be like this. Is there any invalid data? Those kind of testings, data validation testing, they will do by testing team. Okay. So even in the report also. So once this testing team given the green signal to the development team, the what development team is, then they will move the code to UAT phase. Okay. From the development, they will move to testing phase first. In the testing phase, all the testers will do the necessary testing. Then if everything is okay as per the business expectation, if the testing team gives the green signal, then they will move the code to UAT. So UAT means the users. Okay, so the users, business users will test the necessary activities. And as per the expectation, if we are getting the results, means then they will give green signal to move the code into live deployment. Okay. So in live, initially there will be, if the jobs are running on daily basis. Okay, so there will be 1 week hyper period that DataStage development team will take care. After 1 week, then there will be a dedicated support team who will be monitoring the jobs, reports, all the stuff, and they will take care ongoing if any issues. Okay. So this we have discussed. Okay, so any questions, guys? Are we good? Hema, Agendra, Shiva, are you able to follow? Ravindra, sorry.
Yeah, I'm good. Ravindra here.
Yeah. Ravindra, can you please rename your original name?
Yes, sure. I'll do that.
Yeah.
Tomorrow section I'll do.
Srikar, any questions?
No, sir, not from me.
Okay. Yeah, so they have other students has replied that they are required with some personal work. They will follow the requirement. Right. Yeah, so the next one is data models. So this is very, very important. So we have discussed about, right, after the business requirements are clear, the next phase is like we need to build the data models, right? So what are data models? Why we need data models? Okay, so if you are building any project, so they will be having a data model without any project if you take. Okay, so data is stored somewhere, even if it is a front-end application. Okay, so in the front-end application, so the tool will be operating and they will be inserting some data, but the data is stored in somewhere, right? It may be a database. So they will be linked up with. If you take a application like Java, they develop the code and the data is stored. They will consider as Oracle database. Okay, so if it is developed in ASP.NET kind of framework, so they will use MS SQL. Okay, so in my current project, what I am doing is like customer care. I work for a automobile client. So here we'll be taking care of customer service. If customer came for the service, what is the waiting period? Okay, what is the vehicle issue? What is the technical comments? And technical issues comments provided by the respective technician or operator, the engineer. And customer comments, what happens to the vehicle? Any accident happened? Where the accident has happened? With the date. Okay, so all these things will be maintained in a database, and this will be the data will be sent to the business team where they will view the reports in a Pega dashboards. Okay, so we are using front end tool as a Pega. Okay, so here backend we will be supporting data. So we'll be having master customer information, all the details in Hive database. So we'll be execute the scripts, SQL scripts, and load the data into MS SQL in staging area. Again, from staging area, we'll be loading into the data into target tables. Target 4 tables will be there. So in that 4 tables will be combined and integrated and will give one single view access. It's listed all the columns, what and all they need. Okay. And this Pega team will consider those view, what we have given permission to access the data. So based on that data, what is there present in the view, they will display in the dashboards, Pega dashboards. Okay. So here, why I'm telling all these things is, for any project, there will be a data model. So initially, when the project is kick off, so we used to discuss how many tables we need. Okay, so what are the source tables? Okay, so here we should have a rough idea. What is my business? So here in conceptual data modeling, what happens is, so there won't be any table creations and all. We won't create any tables. So first of all, we will have a clear discussion. Okay, so we should have a understanding of the business, and we need to declare what are the entities. Okay, what are all required with the relationship among the entities. Okay, so in the conceptual data model, we are not defining any column. Okay, so any primary key, nothing is defined. At this level, the data model will try to identify the highest level of relationship among the different entities. Okay, so here we'll be having a high level information about the data model, how we can store the data, what are the relationship among the tables. Okay, so they will have this agenda on the conceptual data model. The next data model we'll have is like logical data model. Logical data model here is including all the entities and relationship among them, and all the attributes for each entity are specified. Okay, so how many tables are required? What are those fields? Okay, is there any primary key for the entity and foreign key among those? Okay, table to table. Is there any foreign key? Okay, and here at this level, the data will be in a normalized format. Okay, so it has data in a detail level, so that data will be in a normalized format. I mean, the duplicates are very minimal. Duplicates won't be there. Okay, so here we will be declaring all the necessary attributes and primary keys, all the fields details and all. So, and the relationships also will be mentioned in LDM, logical data model. Okay, so the next attempt, once this logical data model is prepared, these logical data models are prepared by technical technical team, senior tech lead, okay, architect. So data modelers, so they are involved all this agenda. Okay, so they will prepare this LDM documents. Once these LDM documents are done, so we need to create the physical tables in the respective environment. Okay, so here we have to create the column names. So here column names, there will be some criteria. Length of the column name should not contain 32 bits. How many of you noticed this? So if you want to create any table, okay, so I want to table is created. Table length also should not be considered more than 32 bits. Even column length also. Column length. Okay. So column length 32 bytes is the max. Max. 32 length is 32. So beyond 32, it won't consider. You will throw an error. So this we have to consider this in creating the tables. And there will be short forms. We have to mention. Suppose global invoice ID. So global will be there in the physical data model, but GLX, GLB. In table, it will be, you have to create like that. Okay. Invoice number. So invoice number, it will be like INVC. INVC. In table, you have to create like this. Okay, so you cannot write the full name. There are some short forms that we need to follow as per the data model tools, like Irwin, when we use Irwin. Okay, so we need to follow these standards. Okay, so you need to notice this. Okay, and we'll be validating. There is a separate team once the architects they create this data models, and there will be a review team. PDM documents, LDM documents has to review. Okay. Recently, when I joined a new organization, I was in the middle of the project. So they are integrating all the source systems, different source systems from multiple applications. They are integrating everything into one data lake by using Snowflake data, Snowflake Cloud DB. Okay. So my DM asked me, delivery manager asked me to review the PDMs and LDMs. Okay. So whether we are, what are the projects which are going to start the development? Already developed things already they have been taken care. The next month they are going to start this development means. So I need to review those LDM and PDM. Okay. So once review is done, and if I give the green signal, then the development team will jump in and start the development activity. Okay, so there will be a review of the data modeling. Okay, so this LDM, PDM and all. Okay, so here, so once this data model PDM is created, then the actual development will starts. Okay. So here we can see the data, tables physically in our database. Okay. So normally in dev environment will be access to create the table by yourself. Okay. So even some companies, so they won't give us access to create any tables. We need to take the help of DBA, but we need to prepare our scripts. Okay. So the tables, we need to prepare the DDLs. Okay, so DDL creation and all will be taken care by senior tech architect. Okay, so some they will give some samples of existing. They will modify accordingly and create the share the scripts to DBA team, and DBA team will execute those scripts and the table will be created. Okay, so mostly normally in the dev environment they will give permission to create the table by yourself. Okay. So if every developer is creating the table, then it would be a problem, right? So they will give permission to us to create in the dev environment. For QA, pre-prod and production, that and all controlled by DBA team. Okay. So any questions, guys, on data model? So in interviews, they will ask what is the differences between this conceptual data model, logical data model, and PDM. Okay, should you be able to answer when you face this question in interviews? Okay, any questions, guys? Hema, Srikar,
No, sir.
Ravindra, Nagendra.
No, sir.
Okay, right. Any questions, Ravindra? Are you able to follow?
Yes, very much. Yeah.
Yeah. Now let's move on to schemas. Okay, for any project, so there is a schema. Okay, like what is the main table, main tables. Okay, and so here in schema, the purpose of creating schema is like to simplify your data model so that we can establish the relationship among the tables. So here in data warehousing project, we will be creating dimension tables and fact tables. Okay. So the purpose of star schema is to contain one fact table and surrounded by dimension tables. Okay, so let's see an example here. Star schema has one fact table. Sometimes we can create two also based on the business expectation. Okay, so in my experience, we have created two fact tables and related to and 6 dimension tables. Okay, so I work for a procurement process. So anyone has any idea about what is meant by procurement process? So procurement process in the sense like if you take an example of automobile industry, automobile like JCB, Caterpillar. So you can consider example of two-wheelers. In India, we have Hero, Honda, right, TVS. So they will manufacture the vehicles, right? Will they manufacture all the parts related to the vehicle? They will do all the works? No. Only the main key parts, engine, which are confidentiality. So that and all manufactured by that company, respective company. And other parts, no? So they will take the help of supplier. For one part, they will have many suppliers, 3-4 suppliers. Okay. So we are not sure which supplier performs very good. So the contract they will given to 4 vendors. Okay, so they will create a competition among them. Okay, so why we creating competition? If some unexpectedly, if anything happened to any vendor, so they can close the business immediately with them. So they have terms and conditions. That is the reason they have same part they will manufacture by 2 vendors. Okay, so we have seen this in IT industry also. Normally, this product-based companies, they will give contract to 3-4 bakras, IT companies. Why? If one company is not performing, delivery is not good, they will terminate the contract immediately. So they will release the resources. There is no much work here. You can release your resources. Okay, so like that, they will create a competition among them, and they will ask for, can you do with the low cost? Okay, so they will create a competition and reduce the price. So they can get benefited, right? Okay, so like this here, 6 tables. We have created 6 dimension table and 2 fact tables. So in this 6 dimension tables, one is like invoice data. All the invoices, what and all raised by customer. Okay. First one is purchase order, purchase order stage. So purchase order raised by company and invoice raised by vendor. Okay. So I am placing an order. For example, if you go to bakery, so you will place the order first, right? So the shopkeeper will ask you, what do you want, sir? I need egg puff. I need veg puff. I need chicken puff. I need so-and-so drink. Okay. And there is then once you place the order, they will deliver the products. If do you need parcel or you will eat here? Oh, I need parcel. And they will make what on the list order that you have placed. Okay, so the order number will be created and you need to show the order copy to the service boy there. Okay, so they will check your order and give the necessary product and place everything in a cover and they will give it to you and you have to pay the bill and come out from the bakery shop. The same way for any organization, we have to place an order to the supplier. Okay, so once this product is ready, okay, so we have product is ready, boss, then vendor will create an invoice. Boss, this many products I have manufactured, you can check here and please settle my bill. Okay, $100,000. Okay, so then as per the company norms, there will be the bill. Once the invoice raised by the vendor, that has to be approved by client, company. So they'll review the invoice and they will review all the products. Then the invoice, once the invoice is approved, it will take 1 week to credit the amount to their accounts. So this approval process and all will take between 2 to 3 weeks. Some companies, they will take 2 months also, as per their policy. Okay. And the next thing is we'll maintain the supplier data and account distribution data, accounts information, all the financial transactions. Okay. And what are the items that we receive? Okay. So these are the dimension tables, and we have fact tables like invoice, PO fact, invoice fact, purchase order fact. So we'll be correlated these tables, and we have foreign keys in fact tables and reference based on the dimension keys, primary keys in the dimension table. Okay. And Snowflake. So here Snowflake schema, when we created a Snowflake schema is, if you want to develop, if you want to load the data into dimension tables, it will take 2 to 3 sub-dimension tables are required. Okay. So if that is the scenario here, dimension table contains sub-dimension tables. Okay. So in that scenario, multi-dimensions are created on a centralized fact table. So here dimension table has been categorized into sub-dimension tables. So we'll be receiving data from different different versions, and we'll be supporting and loading the data into a dimension table. Okay. So this is Snowflake schema. Okay. Right. So now let's discuss about slowly changing dimensions. So before discussing slowly changing dimensions, we need to go to types of dimension tables. So what are the types of dimension tables and fact tables? Let's discuss this. Okay. So here we have dimension tables. So dimension tables means where it deals with the data to a specific subject of an enterprise. Okay. So suppose sales information, sales dimension. Sales dimension means what? What are the sales transactions happens? And also product dimension. All the product information will be there. Customer dimension. Okay. Store dimension. Okay. All the stores information. Okay. So it deals with any specific subject of an enterprise. So that will be considered as a dimension table. So how many types of dimension tables are there? So dimension types tables can be classified into 5 categories. So what are those 5 categories? So what are those 5 categories? We'll discuss one by one. Slowly changing dimensions. So in slowly changing dimensions, what happens? So here over a period of time, our data will change. Whenever first time when you are loading the data into data warehouse, so here we will be considering as a type 1, type 0 dimension. So what is meant by type 0? So when there is no change in the data, how you load initially? So that time we will be considering as a type 0 dimension table. Okay. And the next one is type 1. Type 1 means over a period of time, data will change, right? Over a period of time, data will change. So when the data is changed, what happens is, when the data is changed, what happens is, we need to update the system, we need to update the dimension table. Okay. So for example, customer database. So here in the customer database, addresses will change, right? Okay. So that we have to update with the latest information. So that is type 1. And here we have type 2 dimension table. So what is meant by type 2? Here current and history both are maintained. Okay, so here in type 1, there is a disadvantage here. Okay, so in type 1, there is a disadvantage. What is the disadvantage? Can anyone of you tell me in type 1? So in type 1, slowly changing dimensions. So there is one disadvantage here.
You lost the history.
Yeah, correct. We are losing the history data. So, but in type 2, here we'll be considering current and as well as history. Okay. So if you don't understand now, no need to worry. So in practical live data stage classes, I will show you how this we can implement. Type 0, how we can implement for the first time. Type 1, how we can implement. Type 2, how we can implement. Okay. And type 3, how we can implement. We will discuss this with the practical examples. Okay. So here in type 2, we'll maintain current and as well as history. If they want to check the history details of a particular customer, okay, so then they have to check their history data, right? So that is the reason type 1 has disadvantage that we are not maintaining history. We are focusing on current information. Okay. And the next one is partial history. So what is meant by partial history? Type 3 dimension. So one more disadvantage here is in type 2 is data is getting piled up. Okay. If company don't want full historical information, just partial information means then go for type 3. So here we'll check the current information and partial history, previous information. That's it. Okay. So based on your organization needs, you need to design the dimension table how you want to maintain. So that is the reason here we'll be calling it as a slowly changing dimension. Okay. Next one is conformed dimensions. So what is meant by conformed dimension, guys? So what is meant by conformed dimension? So conformed dimension. So when we use conformed dimension, it means any dimension table used across the at enterprise level. At enterprise level, multiple applications are using this particular table. Okay. So in that scenario, we'll be calling it as a conformed dimension. Okay, supplier dimension. Okay. So here sometimes no. So supplier dimension is a multiple. I mean, they will use the data from multiple applications, especially in manufacturing industry. Take an example. So they will provide the details of all the supplier information. Okay, so in supplier information, this procurement team will use supplier data and supply chain management. Accuracy supply chain management team will use the supplier data. And when you handling with dealer data also. Okay. So what is the difference between dealer and supplier in case of any manufacturing industry? Dealer is a person who will take care of selling our vehicles. Right? For example, if you want to buy Tata Nexon, you directly will go to Tata Motors where the car is getting manufactured. And first I need a car, I need to book the car. So they simply straight away tell us, go and book your car to your respective dealers. We have authorized sellers across the country. Where you are located? I am located in Hyderabad. So go to your nearest authorized dealer. Okay. You can book car from anywhere. Okay. You can register the car based on your address, what is there in your Aadhaar card. Because the PIN code, based on the PIN code, they will suggest for registration nearest RTA, regional RTO, Regional Transport Office. Okay, so we'll be booking any vehicle through a dealer only. Okay, and supplier is a person who who helps the company in manufacturing a product of a car. Okay. So here recently I have purchased a vehicle. I came to know that the seats are manufactured by some third party person, some SLG Enterprises. I don't know who is this SLG Enterprises. That is a vendor of Tata Motors. Okay. So in Tata Motors supplier data table, they have all this the SLG Enterprises. Supplier ID, supplier name, what was his base office address, corporate office address, or what is the nature of business, everything information will be there. Okay. So supplier is a person who helps the company in manufacturing few products of a vehicle. Dealer is a person who helps us in selling their product. Okay. So they will give just 25% or 30% profit margin of the vehicle cost. Okay. So here conformal dimensions are used across the applications. So supplier table is also a supplier is used across the application, and area, geographical area. Geographical area. So they won't write the full names. They will write sub. SUPP sub means supplier. Okay. So here geographical area. So any table, any dimension table used across the multiple applications, those tables will be calling it as a common dimension. So this is very, very important interview question. Okay. And the next one is junk dimensions. So what is meant by junk dimension? Any junk dimension. Okay, so there are some weights, flag values. We won't do anything. Okay, so if you choose the weight of a product, so quantity, like it's a weight rate. Okay, a junk dimension is a group of attributes at lowest level of cardinality. It contains different and various attributes which are unrelated to other attributes. So there is no relation among the other attributes. So that type of dimensions we will call as a junk dimensions, flag values, weights, and with the flag values, weights, we are not going to establish any relationship. Okay. And the next one is degenerated dimensions. Degenerated dimension means degenerated dimensions means any dimension table. Okay, so that is generated by a system. Okay, it is the attributes which is stored in the fact table itself and not separated dimension table. These attributes called as a degenerated dimension. Normally, ticket number. So when you book the ticket from IRCTC, there will be a PNR number, right? Even if you book a flight ticket, there will be PNR number. So these numbers are generated by a system. Okay, it is stored in the fact table. Okay, so during the transaction data ingestion, okay, so that time we'll be creating this degenerated dimensions. Okay, so the next two dimensions, role play dimensions. It will play a key role in your fact tables. The having multiple relationship among the fact tables or role play dimensions. It plays a major role. Okay. In other words, when it is having same dimension keys, which is related to attributes, maybe a joining conditions, like for example, foreign keys. The best example is foreign keys. So it plays a major role in the dimension table. And because the data is moving from dimension table to fact table with the help of a primary key. Okay. So that is a role play dimension. So any questions, guys, here? Are we good so far? Srikar, Ramendra, Nagendra, Hema. Guys, if you are unmute yourself, you can type in the chat box. Yes. Is it clear? Okay. Hello. Guys, I am audible. Only one person responded. Hema, clear. What about others? Ravindra, are you there? Hello. Ravindra, Srikar. Hello. Hello. Clear, clear. What about others here? Ravindra and Srikar has to respond.
That was clear.
Okay. What about you?
Yeah, you are audible. Yes.
Okay. Yeah. I'm waiting for response, Ravindra. So if you have any doubts, you can ask me now. Okay. So I can explain you one more time. Any understanding gap, the concepts. Okay. So these notes, no, I'm uploading in Drive actually. So Google Drive. So where I will share all the study materials. Yeah. So now let's move on to different types of fact tables. Okay. So here fact tables, we have we'll be calculating the measure values. Fact table contains foreign keys and the measure values. Okay. So what are the measure values? Additive facts. So here these measures are taken across all the dimension tables, like the keys for foreign keys. Okay. Product store key, product key, transaction date, what is the revenue, and store wise, product wise, they can calculate this additive facts, daily sales. Okay. So these are important, especially in retail industry. So they want to know the day-wise sales. So if it's a textile, okay. So they want to know the how many products got sold today. What is the revenue generated? Day-wise, store-wise, product-wise. They will do all this analysis. And product-wise, if they do analysis, then they will come to know which product no one is buying. And they will take action why this product is not moving. What is the issue? Is there a defect from manufacturing side? If the product itself is not good, then watch this retail outlets, they will give 30% off, 50% off to clear the stock. Okay, so you may have noticed sometimes they will give very good offers. Why they give offers here? To clear the stock, not love on us. Okay. So anyway, we have to clear our stock. Let's give with the discounted price, 50% off, flat 50% off, flat 30% off. So instead of keeping the stock in the store, let's the customer can use. So those people who are in the middle class, below middle class, they can affordable if you give a discount of 50%, 60%. Okay, instead of being in the stock let it be rotate. Transaction money will be rotated, right? So if you give 60% hike also, 50% discount also, they will get at least 10% profit margin. Nothing is going to be lost for them. Okay. And non-additive facts. So this cannot be summed up across any dimension tables like ratios, columns, weights. Okay. So these are non-additive facts. Factless fact tables. So these factless fact tables basically fact table without any measures. So it contains only keys. It places a gap between these dimension tables and fact tables. Okay. So these are the different types of fact tables. Okay. So the slowly changing dimensions, here we have discussed, right? SCD type 1, type 2. We'll see this in practical classes. Okay. Type 3. Yeah, right. Surrogate keys. What is a surrogate key? Surrogate key is a system generated key created in the dimension tables. Sometimes the interview will confuse you where the surrogate keys are created. Surrogate keys are created at fact table and dimension table. So this question they asked me when I was attending IBM interview in 2010. I boldly said that surrogate keys are created in fact table. It's a wrong. Surrogate keys are created in dimension tables. Okay, even though I'm saying wrong, I'm boldly say that surrogate keys are created in fact tables. Then I didn't select it. I did not clear that interview. That is my third interview, I can say. After learning DataStage, after updating my profile. Okay, so if you don't know anything, no, have a memorized what they ask. So now, in those days, face-to-face interviews. Nowadays, everyone, I mean, interviews are happening through proxy mode and Teams call. Okay, so those days we had to go to face-to-face interview. Sometimes they will have telephonic interviews. Okay, so if the demand is, I mean, requirement is huge, they will consider only telephonic interviews, they will release the upload. Okay, so as the world is shifting to step-by-step digitalization, then we are flexible and comfortably attending the interviews at home. Okay, so yeah. So here, surrogate keys are implemented in dimension tables. Okay. Now let's see. Primary key. So primary key is unique and not null. Okay. So primary keys are created at a table which is like unique and not null, and a unique key. So unique key is nothing but unique. The data is unique, but nulls are allowed in the unique key. Okay. So that's it, guys. So I have covered data warehousing concepts. Okay, so let me share you the study material. Okay. So this is a map actually. So here the recordings will be available here in the Zoom link. Okay. Sorry, YouTube link. So I'll be updating this link here. You can go through this recording link in YouTube. Okay. And the next thing is we have this files for practice. Once the practical session starts now, you can use these files. You can download this folder, move to VM. And this is the study material, data warehousing concepts. So this is the presentation what I'm sharing here, the same PPT. Okay. And dimension tables. Where is dimension tables? See here. Okay. And then the next thing is so this is DataStage study material. Okay. There is and I will be sharing FAQs also at the end of the course. Okay. And this is a project templates. So I'll be sharing 3 projects, 2 manufacturing projects, 1 banking project. Okay. And the next one is SQL study material. This is study guide, which I will generally give to the students, and FAQs. These are FAQs. So DataStage FAQs I will give at the end. And this is the Unix study material. Okay, Unix commands, part 1, part 2, part 3. Okay. and these two are assignments case. Okay, so here solutions, questions are there. So at the end of the course, you have to do these assignments. I will give with answers also, but you should be practice the assignments without watching the videos. Okay, until unless if you stuck any logic, then you can refer my videos. Okay. So that's it, guys. So in tomorrow's session, we'll continue with data stage. Okay. So we'll jump into data stage. So we have discussed data origin concepts. Okay. Yeah. So any questions for me, guys? Any questions? Yes, are you getting any background noise from my side? Some construction is happening here. Yeah. So that is the reason.